what are the solutions to 3x squared plus 12x plus 6 equals 0? Right off the bat, and I do encourage people to do this who are studying for the SAT, always look at your answers first. You can get clues in the multiple choice answers that are provided to you. Here, every single one of these includes a square root, a plus or minus, and a square root. What that should tell you if you are, if you've studied your factoring, is that this won't be factorable. You're not going to end up with a square root if it's an easily factorable, like, oh, it's going to factor into 3x plus 2 and x plus whatever. If you can factor it like that, you're not going to end up with these square roots. It just doesn't happen. If you see those square roots, it means you're going to need to use the quadratic formula, not factoring. So that will save you some time. If you look at those multiple choice answers and go, wait, there's all square roots, I should just jump to using the quadratic formula. I should not waste my time trying to factor by grouping or anything like that. So what is our quadratic formula? It is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And they do not provide this as part of the reference at the beginning of this section. It is not there. This has to be in your head, especially because this is not a calculator portion. So you can't just use your calculator and, ask it what's the solution to this. You have to know this. Sorry. I know it's kind of a monster of a little formula to remember, but you got to do it. So negative b plus or minus square root of b squared minus 4ac all over 2a. A, b, and c are referring to the constants. Here they are 3, 12, and 6. Those are our a, b, and c. So we're just going to plug all those in and then do the math. The hardest part of this is remembering that. The second hardest part is being careful when you're doing the math, making sure those negatives are done accurately, the plus minus, that you take that into consideration. Okay, so our b is a positive 12, so we're going to put the opposite of that first, which would be a negative 12, plus or minus. Again, our b is positive 12, so that goes in here, 12 squared, minus 4 times a times c. 4 times our a is 3, and our c is 6. All over 2 times a, again our a is 3. And now this is just about being very careful in your math. So inside here we have 12 squared. 12 squared, or 12 times 12, is 144. Minus 4 times 3 times 6. 4 times 3 is 12. 12 times 6 is 72. Especially for these non-calculator portions, if you are feeling rusty on your times tables, these non-calculators, it's so good to have these times tables in your head up to 12 times 12. It's going to save you a lot of time, so you're not having to figure these things out by writing them out. Okay, so 144 minus 72. Since we said this was a little shortcut here, this is 12 times 12, and this is 12 times 6. So if you subtract them, it's going to be 12 times 6, because 12 times 6 times 2 would equal 12 times 12. So 144 minus 72 then is going to be 72, or 12 times 6. Okay, so now we're in the simplification part. Also, 2 times 3 down here is 6. Okay, but as you can see, this does not match any of the answers, so we need to simplify this further. 72. Are there any perfect squares inside 72? If you don't know this offhand, factor trees are your friend. And you can start doing a factor tree and saying 2 times, it's even 2 times what? 36. At which point you might go, hey, 36 is 6 times 6. That's a perfect square. Here are those multiplication tables coming in handy again. But if you don't have that in your head, just keep doing a factor tree. Like say 36 might be 3 times 12. 12 is 2 times 6. 6 is 2 times 3. And you're looking for pairs of numbers. So you're like, 2 and 2, and 3 and 3. So 3 and 2, or 3 times 2, times 3 times 2. 3 times 2 is 6, so 6 times 6. If you like more details on factor trees, I'm going very quickly because there's so many problems here. I have links on all the topics that we're covering here, more detailed, in-depth on these topics like factor trees and quadratic formula and stuff linked in the description below. Okay, so now I know 72 is 36 times 2. So, okay, I'll put that in there. It is 36 times 2. And now we can really start tidying this up. So I'm going to rewrite that as negative 12 plus or minus square root of 36 times square root of 2, because you can do that. One of those great things with square roots, with radicals that you can do. And what is the square root of 36? It is 6. Hey! So negative 12 plus or minus 6 times the square root of 2 over 6. But if you'll notice, that still does not match any of our options. So now we need to look for a greatest common factor. And you're looking for it not under the radical anymore. That is locked off. You can't touch it. You're looking at these 3 numbers. Is there anything that goes into all 3 of them? Or any of them? Yes, 6. So I'm going to pull out a 6 on top. So if I pull out a 6, what is negative 12 divided by 6? It is negative 2. What is 6 divided by 6? It's 1. So it just disappears. Now I have 6 times negative 2 plus or minus square root of 2 all over 6. Since this is saying multiply by 6, then divide by 6. Or if you know with your fractions, top and bottom can cancel out if they're being multiplied. Those cancel out. And I am left with negative 2 plus or minus square root of 2. Let's scoot that over. Boom. And that is option A.
If this was helpful or useful in any way, please like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.